Okay, thank you. When I was in college, I'll back it up. When I was in high school and I had gone through advanced algebra and trigonometry with the most boring teacher in the whole world, I thought, okay, I'm done. I'm not going to take any math during my senior year. Oh my gosh, I don't like this. And then, so senior year I had other classes and I could get an A in anything else. It's just that in math, if I took a math, I had to work and then maybe get a B, but hopefully get an A. So senior year, I had no math and I decided I miss math. I shocked myself. I thought, I miss the challenge that math can give me to make me have to work harder. But then, so okay, I chose a career that I would need to take some math for. Then when I was in college, I started tutoring chemistry and physics and stuff, and I kind of liked that. And so junior year of college, I changed my major and I decided I'd become a teacher. And I thought, okay, I'll teach for like 5 years, get it out of my system, and then I'll go do something else. So my idea of just teaching for 5 years was in 1978. And I just have never totally gotten it out of my system yet. I just love helping kids learn. And like she mentioned, sometimes it's Pikes Peak Community College students who are maybe 40 years old and they haven't been in high school for a long time. And they need to take those beginning math classes and I'll help them survive and thrive if possible. I just enjoy helping people. In 2000, once I did leave teaching, I started tutoring because I just couldn't totally leave it. And I kept on volunteering. So actually I have 27 years of volunteering in schools. And I taught 19 years where I was paid and 27 years where I volunteered. And I finally made myself quit doing that and thought maybe I'd be done. No, I just love tutoring. So I tutor 6 days a week. And I just have a blast. I have a math website that has math and algebra and geometry, and that is free to anyone in the world. And then I have 8 math game apps that are all available on Apple devices. They're all free and can be for anyone in the whole world because of the internet. And then I have, and those have been downloaded in over 90 countries, which I didn't expect. Okay, I'm helping people in 90 countries. I did not expect that. And they've been downloaded over 75,000 times, which I'm happy for too. Like in this past 30 days, there was like 500 of them downloaded, one kind, 500 of them downloaded somewhere in Mexico. To me, that means it's a school downloading them to all of their iPads or whatever they must have. So good, because then they'll not just get used once or twice, they'll get used by students and students and students and students. Once they have the app, which was free, they have the app. They can use it year in and year out. So I'm happy to help those. Last month, there was like 504 of one particular app, and that was all downloaded in Iceland. I did not expect that. It's in 91 countries, so you name a country, it's pretty much where my apps have been downloaded. Happy to help. There is one app that's coming, I paid for, I used my tutoring money, have a company, use my tutoring money to pay for all my computer stuff and my graphics and everything. And I enjoy that too, because then I'm helping other people use their skills and get paid for it and put it on their resume. Like the person who developed the graphics for all of my apps, she got it, and it looks good on her resume that she can say it's been downloaded in 91 countries or whatever. She now is working on an animation project for one of the Smithsonian Institutes in Washington, D.C. So good. I'm glad that it was able to help her perhaps. And I can still call her if I need new apps and I need the new graphics for it. So I'm happy to help in that way. The Apple apps, 4 of them have been converted to being able to be on Android devices. And one more is being converted. He is also coding it so that you can tap that you want it in French, or you can tap that you want it in Spanish. So that one I actually am charging for, a big $1.99. But it should make it more available throughout Europe and Spanish, so it should make it more available in Central and South America. So I'm hoping to help people. As long as they sign up for it, they got it forever. Then I would be happy to help you. One of the things that has been happening in geometry is they've been pushing it farther and farther down, and they're not doing nearly as much of proofs, which is okay with me. But they're blending in a lot more algebra with the geometry. And even when you're in algebra, they throw in some geometry. So that's what I guessed at for high school. I guessed that I would help you in algebra and geometry blend. Feel free to keep eating as I'm talking. You each have a folder, and you're welcome to open that up. The first one just tells our agenda for tonight. The topics I will go through: right triangles, parallel lines, crossed by a transversal, circles and chords, and then perimeters. Then there's all my information for my website and my apps in case you want to know. And here's a picture of it. Then your first one, we'll stop at this first one. It's the squares of numbers. If you need something to write with, here's a bunch of mechanical pencils. I do want them back by the end of the night, but you're welcome to come on up and get a mechanical pencil, please. Oh, there you go, deliver them. Sure. Half of one. Gretchen, his fell apart. He's only got half of one. Some people are whiners, you know. No, just kidding. Okay. So let's go through the squares of the numbers. I'm sure you know quite a few of them. What's 1 squared? Did I hear someone say 1? Okay, what's 2 squared? 4. What's 3 squared? 9. What's 4 squared? What's 5 squared? What's 6 squared? 36. What's 7 squared? 49. What's 8 squared? 64. What's 9 squared? Yes. And what's 10 squared? 100. Okay, now, in case no one's ever pointed it out to you, if you're at the square of a number and you want the square of the next number, you take that square, you add this one and this one, they would be 3. 3 plus 1 makes 4. These two make 5, plus 4 makes 9. These two make 7, plus 9 makes 16. These two make 9, add that, you get 25. 11 added to this makes 36. 13 added to that is 49. 15 added to that, 64. 17 added to that is 81. 19 added to that is 100. How many ever had that ever told to you? How many have never ever seen it, but it's kind of cool? I mean, how many think that's about the closest they're going to come to saying that math is actually cool? And if anyone comes in, if you would want to grab a folder and a mechanical, if they come in. I thought somebody had, but they're not. Okay. So now we're going to use that. We're going to apply that idea. So if we want the square of 11, we add 10 and 11, that's 21. Add it to 100 and you get 121. Okay? Then these two make 23. Add 20 and 3 and you get 144. 15 squared, I jumped now. 15 squared, does anybody know it? 225. 20 squared looks a lot like 2 squared. So it's got a 4, but then it's got a 0 for each of the 20s. What's 25 squared? Anybody know that? 625. Okay, it's a good one to know. Since 20 squared is kind of like 2 squared with 2 zeros, 30 squared would be 900. And then 40 squared will be 1600. 50 squared would be 2500. Okay, so now I'm going to figure you have those all written down. We're going to apply that by your next worksheet, which is has some right triangles on it. So that is the Pythagorean theorem. So that one says Pythagoras must have been done like watering the camels or something, and he must have been scratching in the sand and went, hey, look at this. And now everybody has to learn it in the whole world, generation after generation. So it's called the Pythagorean theorem. And it says that if you have a right triangle, that means it has a right angle, then the two sides that make the right angle, if you square it and add them up, it becomes the square of the third one. How did he happen to figure that out? I don't know, but he did. So, Pythagorean theorem, and then if you reverse it, if a squared plus b squared equals c squared, okay, if 2 plus 8 equals 10, then the 2 is the 10 minus the 8. Agree? Okay, so not only this, we can say, well, then a squared is the c squared minus the b squared. And b squared is c squared minus the a squared. So now on your first problem, you've got a right triangle that has a height of 5 and a length of 12, and we're supposed to find the hypotenuse. The hypotenuse is this long side that's across from the right angle. So that means, and it really wouldn't matter which order, 5 squared plus 12 squared equals c squared. What's 5 squared? 25. What's 12 squared? Okay. Equals c squared. So c squared equals 169. C then is the square root of 169. So c is, anybody want to guess? 13. Did you swallow a calculator when you were younger? No? You just know stuff. Okay. I like that. Okay. Go ahead and do problem number 2 and 3. Okay, go ahead and do, that one just got done at the board. Go ahead and do problem 2 and 3, please. Sure, you can circulate and see if they want help. On that problem number 3, it doesn't work out real pretty as an answer. So if you just leave it as square root of 68, good enough. Okay, good enough. Then the last ones, it isn't c squared that's missing, it's either a or b. So go ahead and try to start doing those last ones. Now, can we go on to the next worksheet? You can always finish that one later. It kind of looks like algebra when it has a variable in it. That's why I thought Pythagorean theorem will classify as an algebra geometry blend. The next one has right triangles again. This time I want you to figure out what's the missing angle. Well, the grand total of the degrees in a triangle is how much? How many degrees are in any triangle? 180. So if I know one of them is automatically a right angle, that's 90. So then the other two must be a total of 90, correct? Those two must add up to 90. So on number 1, you have 45 plus x must be 90. 45 plus what makes 90? 45. Yes, another 45. Okay, number 2, the 30 and the x must make 90. 30 plus what makes 90? What's x? 60, yes. It will get harder. Okay, then on the third one, 72 and x makes the other 90. So what plus 72 makes 90? 18. Okay, now it starts being algebra. Okay. So this angle plus this angle must be equal to 90. So 1x and 1x makes 2x. So 2x plus 50 equals 90. Then I can subtract 50. If I take 50 away from here, I get, or do it this way. What plus 50 makes 90? 40. So this must be 40. 2 times what will make that be 40? 20. Yes, x must be 20. Okay, then the next one. Ooh, got variables again. Okay, we'll do number 5. 2x plus the 4x plus 6 have to become 90. 2x plus 4x will be $2 plus $4 would be, think money makes math more interesting. That's my conclusion. 2x plus 4x is 6x. 6x plus 6 equals 90. Well, this must be in the 80s. 80 what plus 6 would make 90? This must be 84. Yep. Subtract 6, you get 6x must be 84. How do I undo multiplying? Divide. Divide by 6, divide by 6, x equals. 6 into 8 is 1, that's my tens number, with 2 left over. 6 into 24 is 4. So x must be 14. If x is 14, how big is that top angle? It's 2x. So that angle would be 28, because it's 2 of these. And the other angle is 4x plus 6. 4 times 14 is 56, plus the other 6 is 62. Yes. Plus, once you know this angle, subtract it from 90, and it's got to be that angle. Okay. Now go ahead and do the last one. Okay, ready to move on to the next worksheet? Okay, the next, let's go ahead and move. Does anybody want to say what they got on that one, or just keep moving? Could be, I didn't do it. 2x tangent, x is 40, yes. So then the angles are 40 and 50. Okay, the next worksheet has parallel lines that are crossed by another line, and that line is called a transversal. Okay, and it just so happens that when it crosses a set of parallel lines, then a whole bunch of angles are congruent to each other. All of the acute angles are congruent to each other, and all of the obtuse angles are congruent to each other. So if I know this one's 60, then this one's 60, this one's 60, and this one's 60. If this is 60, how many degrees to get all the way over? 180. So then if this part is 60, how much is this angle? The whole thing is 180, and I already have 60. Think money. If you have $60, you want 180, you need how much more? 120, that's right. Okay, now your first problem is simply parallel lines, and it wants that angle up there. And it looks like, how am I ever going to do that? I called this session, Let's Figure It Out, because this is when it happens. Let's figure it out. I don't know, I'll use what I know and apply that and see if I can get to where I need to get. Okay, if this is 115, then I want you to label all of the obtuse ones as 115. Okay, there's 4 of them that are obtuse. So they all have to be the same. I think it's a legitimate question to say, how's this ever going to help me in life? When will I ever use algebra? You may not use algebra and you may not use parallel lines in your life, most likely, but it teaches you how to think and it teaches you to be able to kind of stick with it and figure it out. And that is valuable no matter what career you go into. So figuring it out, taking what you know and figuring it out is a good thing to have. So if this is 115, and this is, I'll use this, it's less interrupted. Okay, this whole thing is 180. So if this is 115, yes, which means every one of these acute angles is 65. And now we have a right triangle. We know one angle, we know the right angle, so whatever's left must be this angle, which is what you just learned a worksheet or two ago. Okay, so how much is that? 25. Okay, 25 degrees. Try to do the next one. And for some silly reason, we're going to skip numbers 3 and 4 because I turned it into sine, cosine, tangent kind of stuff. That's not what we're going to do tonight. So just do number 2. And then we'll go on to more worksheets. Okay. 10. Okay, give you another minute to do that problem number 2, and then we'll go on. This one, this kind of activity doesn't have so much algebra per se, where you work with X, but just taking the idea, if I know this, and I know this, then I know this, and then I know this, and then I know that. That's another ability that algebra improves on for you. Geometry does that too. It's called the transitive property. If I know A and if I know A equals B and B equals C, then A equals C, which makes sense. If my birthday is the same as her birthday and her birthday is the same as Delia's birthday, then my birthday is the same as Delia's birthday. Makes sense in real life when you think of real things. Okay. We're going to work on this one, and it has a lot of angles on there, and I only give you 2 of them. Knowing that and applying what you already know, you should be able to figure out all of those angles. And I hope you think this is fun. That's always my goal. Okay. If this is 92, how big is this one? 180 minus 90 and then minus 2. How big is this one? 180 minus the 92 would leave me with 88. Okay, so this one's 88, which means this one across from it is 88. And then it means, if we go down, it means this one's 88, and the one across from this is 88. And if that's 92, then that's 92. These are called vertical angles when it's formed by 2 lines crossing. Dumbest name for angles ever. What is vertical about those angles? Nothing. Why did somebody call them vertical angles? I don't know. But it just is what it is. Now, we happen to have 2 angles of a triangle. So how much do 32 and 88 add up to? 122, yep, which means these 3 angles together make 180. If I take out 122 of them, I'm left with say it again. Thank you. Yep. Oh, well, that makes the subtraction easier. Okay. So, what do we get for this angle? Pardon?
Sorry.
So these three together make 180. These two make 120. If we take that away, we're left with 60. If this one's 60, then this one's 60. And then you go down, and that was hanging underneath the parallel line, so this one's 60. And then across from it, the vertical angle is 60. So we just found some more. Now, if this is 60, then this obtuse angle is 120, which means the one across from it is 120. Same thing up here. Okay, then we can go up here. 32 is across from this angle right up here. So that angle must be how big? They are vertical angles, therefore this one up here is 32, because vertical angles are congruent. And then we can figure out these two. 180 minus 32, 180 minus 30, and then subtract 2. So what would those be? 148. And that would be on this side and on this side. And I think that's about every angle possible. Okay. Okay, raise your hand if you thought that was kind of fun. Oh, okay, not yet. Oh, okay. Okay, then I have 2 more for you. So you can still think it might be fun by the time I do 3. Okay, so try to do the next ones and we will circulate. I don't think I introduced you, huh? This is Ellie. She is in high school and she's in pre-calculus? Pre-calculus. And so she helps me doing some tutoring sessions sometimes, and her mom is Gretchen, and she helps too. So we will be happy to help you do it, do the next 2 worksheets. Okay. Okay, I'd like to go on to the next worksheet that's called circles and chords. And the chords are just segments that are somewhere inside of the circle, from the circle to the circle. And there just is a magical thing that happens when you have 2 chords crossing. When you have 2 chords crossing, they cut each other into specific amounts. How somebody sat around and figured this out someday, I don't know. But see how this one diagonal is 4 and x, and the other diagonal is 3 and 8? Just so happens that the 4 times x equals the 3 times 8. And then I've already got that first one worked for you. 4 times x then is 24. Divide by 4 on both sides. 4 times what makes 24? 4 times 6. So now you go ahead and set this one up. So the 4 times the x equals the 3 times the 12. The next one I made decimals. Oh well. 3.75 times x equals 2.5 times 6. The answer is not too bad on that one. Okay, and I'll circulate and they'll circulate. This one should go faster. Let's do the last worksheet, or at least get started on it. That's definitely a blend of algebra and geometry again. Tangents are segments or rays or lines that touch the circle in just one point. And so on each of these, you have a tangent that touches and a tangent that touches. If those tangents happen to come from the same point, then those are congruent tangents. I know you're happy to know that, but it just so works out. Geometry is like finding out what's true in nature and then telling people about it, making them have to learn it. There's a whole bunch of realities in nature, and this is just one of them. That when these 2 tangents came from the same point, then those are equal. So 18 has to be equal to the x plus 2. What plus 2 makes 18? X must be 16, correct? So that's That's it, you're done. However, number 5 gets a little more complicated. So this time you have x in both of them. Still, the thing you know is that the 6x plus 1 has to be equal to the other one, 8x minus 5. Now you have x on both sides of the equal sign. It's okay, work it out, figure it out. We're going to subtract 6x, 6x from this side. When we do, it's gone, and we're left with 1 equals. If I have 8x minus 6x, I now have 2x. And then I still have my minus 5. So now I have to move my numbers to the other side. How do I get rid of subtracting 5? Yep, add 5, add 5. So now I get 6 equals 2x. I like my x on the left. So 2x equals 6. 2 times what is 6? 3. So x must be 3. And then if you say, oh, prove that. Oh, okay. 8 times 3 is 24. 24 minus 5 would be 19. 6 times 3 would be 18 plus 1 is 19. The nice thing is, in geometry, there's hardly any negative numbers. That's pretty cool. And then a lot of times you can check your work in geometry. So do a couple of those problems, and then I would like you to, we'll pull up my website on the screen and we'll go through some of it so you can see, oh, this is helpful, or at least it could be. So go ahead and take a few minutes to work on that. If you need to go do a bathroom break too, that's fine too. Okay, if you would pull up my website, monumentalmath.com.
Did you get to try that?
Before you sign in, you're going to see what's called a carousel. It's where little screens are moving across, and it shows you my apps. And if you tap on an app, it'll take you right to the Apple Store, and you can download it for free. Then later on, it shows you a Hopscotch app, and if you tap on that, it'll take you right to the Apple Store, right where that app is. So that's convenient. Okay, and then let's go to, so if you would go to your upper right where it says sign up, then you need to, it'll show you, you need to put in an email address and then give yourself a username that you'll remember and yourself, pardon? Up there, she's already signed up, so it doesn't have it, but it's up there in the upper right. It says log in and it says sign up. Log in and sign up. Oh, if you have your, okay, yeah, if you have it tilted upright, it probably is inside of this little.
That's where we're just looking there.
There we go.
Oh, sign up right here.
Sorry.
Okay. Cool.
Oh, here.
And it's really easy to forget your username and password. If you want to write it down somewhere, you could write it down on the inside of your folder or something. That way you'll have it. Then she's already signed up. If you sign up, you'll see it's got 4 categories: math foundations, challenging math, algebra, and geometry. If you would tap on the math foundations, please, and there'll be a long list. And if you start scrolling down, you'll see hundreds of topics. And then if you go across, it tells you how many sets of topics there are to practice that one topic. Okay, if you would, yep. And this starts out with first grade. I don't have much in the lower elementary. Most of mine is upper elementary and then into middle school and somewhat high school. Okay, if you would scroll down about halfway, keep going down this list. It's got addition, keep going down. Go over on the right and just start pulling down that.
Sorry, this laptop is not good.
Huh.
Oh, hold on.
There we go. And you'll see round to the nearest 10, 100, 1,000, multiples of real life. To me, math should, yes, prepare you for the future, but at some points it should be something you can relate to in real life. So that's why I have some topics that are real life, dances, catering, yearly salary, things like that. Dirt, distance equals rate times time. Dirt is an easy way to remember that. Distance equals rate times time. Then it goes into all kinds of fractions. Would you go down to fractions, simplify completely, and you'll see there's 10 sets. That tells you, I think it's a really important topic. And I want to give you plenty of practice. Let's start with set 1, if you would, please. And if you can all find simplify fractions, simplify completely, set 1. And a lot of times there's videos. No, don't play a video. You have them on hundreds of these. That was another person. I hired a former student of mine who was getting a communications degree. I said, do you like doing videotaping? Do you like to edit videos? Okay, you're hired. So she helped me create a lot of videos. And you can rent out the studio at Library 21C for free. So that was pretty cool. So go ahead and go down. There we go. Problem number 1, 9/12. Well, 9 and 12, 3 can go into both. 3 goes into 9 3 times, and 3 goes into 12 4 times. So yes, 3/4. And you submit the answer. And then this progress bar keeps going. Yes, go ahead, 1/4. Okay, the next one is also 1/4, but I want you to put in the wrong answer. Okay, and we'll see. What happens is that the little blue that says you're on this problem, it turns yellow, which you can think of as like a caution light. So it cautions you and it gives you a second chance. You can go, oh yeah, 1/4. So now go ahead and choose the right answer. And it's like it never happened. It doesn't remember that. So that's kind of convenient because we learn from our own mistakes and stuff. If you get it wrong twice, it turns red, and then it just goes on to the next problem, because in math, you're going to inevitably have some things wrong. That's okay, life goes on. So 2/4 is the same as 1/2. Okay, now, would you go back up to the upper left where it says Monumental Math? On the top banner, yeah. That takes you back to the home screen. Let's go over to Geometry. And that first one, find the measure of the third angle of a triangle. We did that tonight. If you know 2 angles, one of which tonight was 90 degrees, if you know 2 angles, you can find the other one. If 2 angles are 30 and 50, that's a total of 80, so the other angle must be 180 minus 80, which is 100. Yep. And then if they're 50 and 100, what's left to make 180? 30. Okay. All right. Now let's go back up to Monumental Math again. I know I'm speeding you through it because I want you to see it. Okay, over to Geometry, and then complementary angles, perimeter. Let's go down to rectangle perimeter, the 4th thing down, the 4th topic. Oh, okay. No problem. 4th one down. Let's go to set 1, yeah. If it says try this, it means you can try it without actually signing up yet, but you're signed up, it's free. I don't pester you with emails. I don't sell your emails. Somebody said, how do you make money on this website? I don't. It's just there. It's already been paid for, and then I just do a yearly, I have somebody that's on tech support, which is my son, who's a software engineer, who made the website, and he does my tech support. So if you ever have a problem, and you go down to the bottom where it says contact us, you can send him an email. This doesn't work. Tell him where, and he'll take a look at it. Okay, 3 and 4. If you have a rectangle, so what I'm telling you on this is if I give you 2 sides of the rectangle, what's the perimeter? Well, these 2 make 7, these 2 make 7, so the perimeter is 14. So next one, 4 and 7. So if this is 4 and this is 7, This much is 11, that much is 11, so 11 and 11 makes 22. It should, I don't want you to have to use a calculator. I want you to develop that calculator in your head and be able to do mental math very nicely. Okay, go ahead and put in 22 and, 4 and 8, we're on the next one. Okay, and yes, 24, you're right. Okay, let's go back up to monumental math. Cool. Let's go to algebra. One-step equations, whole numbers, no negatives. I think we overemphasize negatives way too much and way too soon. Why? I haven't figured out. So I try to not emphasize negatives. All my first ones are just, yeah, if you would scroll down, then you'll see how many sets there are. Yep. Two-step equations with whole numbers. Yep, that top one now. Okay, set 1. Okay, you can scroll down. I show the example problems. 2x plus 2 equals 14. Okay, 2x plus 2. What plus 2 makes 14? 12. So that 2x must be 12. So 2 times what would make it be 12? 6. Done. You parents are really on top of things. I love it. Okay, 2x plus 3 equals 11. What plus 3 makes 11? 8. So 2x has to be 8, so x has to be 4. 3x plus 2 equals 11. So what plus 2 makes 11? 9. So 3x must be the 9, so x must be 3. Okay. Now let's go back up. I don't hear anybody clamoring for more, so I'm going to go. Okay. Actually, let's go to algebra again, and you'll see more. Some of you that are in algebra are doing things like multiplying binomials, squaring a binomial, multiplying to get difference of squares. You learn how to multiply like in 3rd grade, and then you learn how to divide. Same thing in algebra. You learn how to multiply all these binomials, and then you learn how to factor to get back to binomials. And it's like hard until it suddenly clicks in your brain. Then it's like, oh, now I know what to do. And that's good. Lots and lots and lots of topics. If you would go down to the very bottom, okay, x and y graphing, identify the graph given the equation, that third from the bottom. Let's go to set 1. Identify the graph given the equation. Okay, up a little higher, because we have to see the equation. The equation is y equals x plus 4. The plus 4 means that's where it crosses the y-axis. And then the x, there's only a 1 in front of it. Well, it happens to be this. This is the answer. From that 4, you go up 1 over 1, up 1 over 1. So anyhow, this ends up being the answer. So there's graphing ones on there, and then there's the reverse. I give you the graphs, you figure out the equation. And there's lots of practice on that. That's hard for students, so practice it for free. And if you make mistakes, oh well. Learn by practicing, okay? And it is time for you to be able to go. Thank you. In your folders are all of the printouts for all of the problem set titles for algebra and geometry. If anybody absolutely wants the titles for everything in Math Foundation, it's 12 pages long. There's a lot of problems there. It's thousands and thousands of problems. So you are free to go. Thank you for coming and thank you for being a part of it. Parents, thank you for participating and bringing those children. Cool. And if you want one of these for Math Foundations, you're welcome to it.